Okay, so hopefully you can figure this out. I've already started to write this, but 132, um, Z score corresponding to the X score of 132 is exactly 2. If you want the formula, then you can subtract the mean from it and divide it by 16 because that's the standard deviation. And you can clearly see, oops, that's not what I meant to say. Um, Okay, so this will give you 2. And again, and that's because 32 is exactly twice the standard deviation of 16. And you add 100 to 32, you get 132. Right? I hope by now you understand this 2 is not just a random number, right? This tells you that 132 is the value that is 2 standard deviations above the mean, right? How about 92? Well, for 92, the difference between 92 and 100 is -8. Okay, -8 is exactly half of the standard deviation, except it's negative. So this will be -0.5. And this calculation will also show you -0.5, but you can tell that the answer has to be -0.5 because 8 is exactly half of 16. All right, number 2, what percent of people have an IQ between 100 and 132? So that will be, in this picture, all those people between 100 and 132. That's between 0 and 2 in terms of the Z scale, right? And so if you look, let's go up in here. If you look at 2 standard deviations, remember this, that was 4772. So from the table, because you're talking about the area under this curve between 0 and 2, in using the Z values from the table, the answer is 47.72%. Now, this is a powerful statement. Okay, what percent of the people have IQ between 100 and 132? And you say it's about 47.7%. Very precise. Okay, and that's assuming that the IQ tests are normally distributed with the mean of 100 and the standard deviation of 16. And yeah, that's it. What percent of the people have IQ less than 92? Right? Now, 92 happens to be around here. It's not exactly 1 standard deviation about below the mean. It turns out to be -0.5, right? Okay, so here's the picture. Now, this is a little hard one, so maybe I should draw it over here. Okay, give me just a few seconds, and I'll draw this picture. Okay, so 92 is to the left of 100, and we are asked for the percentage of people having IQ less than this, right? Now, we really haven't done anything like this before because the chart or the table gives you the area between the middle, where Z is equal to 0 to this, right? So how do you know what this is? Now, the Z score here is 0. Z score here is -0.5. Okay, so what it is we are going to use the symmetry, right? Do you realize that this has the same area as between the Z score of 0 to the Z score of 0.5 on the right? Okay, and that's because the symmetry, actually this, sorry about that, this area, this orange area corresponds to this orange area to the left because of the symmetry. And this orange area is something you can calculate or you can look up. For the Z score of 0.5, the probability is 19.15%. So this part has 15%, right? The number here is 0.1915. So 19.15% of the population or of the scores are between 0, Z is equal to 0, and Z is equal to 0.5. This also, by symmetry, works on this situation here as well, okay? And so that is a key. Now, you know that to everything to the left is 50%. Okay, so let's guess how you find the answer to this question. What percent of the people have an IQ less than 92? The answer is 50%, everybody to the left, minus this area here. All right, so the answer to this question is 15 minus 19.15%. Let's not include the percentage symbol. And the answer here is going to be 30.85. Okay, did you get this? The reason I had to subtract is because I needed to know this area to the left of 92, and I know everything to the left of the mean, that's 50%, and I know this area between, between z is equal to 0 and 0.5, except it's negative 0.5, but by symmetry, I know that this has 19%, and so is this part, and so I have to do subtract 19.15% here from 50% to get this area. All right, so that's how you can calculate these percentages. All right, now you can use a more comprehensive table, which is what I was showing you here, right? And this should be found in these in the module, in the same module where you find this lesson. And so that's what you can do to get the answer here to this last question. All right, let's take a look at this. What else is normally distributed? Are you guys familiar with LDL? Okay, and HDL? HDL is the good cholesterol. LDL is the bad cholesterol. I happen to have a rather high cholesterol, thanks to my ancestors for that inheritance. And so mine is about over here, okay? What does that mean? Again, people's cholesterol levels are normally distributed. And so suppose that the cholesterol levels of humans are normally distributed with a mean of 178. Every time you do a problem, a normal distribution, I highly encourage you to draw a bell-shaped curve like this and put a line in the middle, okay? And as soon as you write that, you draw this line here, go ahead and write down the mean right here, okay? This is the X score, that's the data. 178 stands right in the middle of this curve because that's the mean. The standard deviation is 41, okay? So think about this is M and this is mu. This is mu and this is sigma, right? What percent of the people have a cholesterol level over 200? So I'm talking about that part. Okay, the first thing we have to do is, remember this is the X score. I have to ask myself, what is the Z score corresponding to 200? And notice here, by the way, all these X values are different. The average on the first one, SAT was 500. And for the IQ test, that was 100. And now we have an average of 178. And that's why we have to normalize using the Z values in order to find the answers using this table, right? So Z of X, that would be 200 minus 178. That's the deviation. You divide it by 41, okay? And that's going to give you this value, 0.536, approximately 0.54. Okay, so you can round this up to 0.54. What this is saying is 200 is 0.54 standard deviations above the mean. Okay, not quite one standard deviation above the mean. I mean, if you add this and this, you get what? 219. 219 will be exactly one standard deviation above the mean. But so 200 is less than one standard deviation above the mean. More precisely, it's 0.54 standard deviations above the mean. That's what the Z-score is telling us. Now, to find this value here, okay, we don't know what percentage is here by the table, but we can find, let's see, what color should I have for this? We can find this part. Okay, because this is 0, right? I mean, the Z-score here is 0. And what did I say the Z-score of for 200? 0.54. Okay, so I need to know the area or the percentage between 0 and 0.54. Notice I can't use it here, right? And that's when you go to the better standard deviation chart I gave you, 0.54. How do you find this? Here's 0.5. 0.54. In order to look up this number, I look at 0.54. Okay, because this is a more precise table, I have to look in 2 steps, 0.5, and then you go down on this row to 0.04. See that? So this number is what the area is between 0 and 0.54. Okay, so did you get this? If you're looking up the number or the percentage corresponding to the area between 0 and point, so the picture I'm drawing is more like this. Here's 0 and then 0.54. What this table is saying is between these two z-scores, I have 20.54% of all the data values, 20.54. Right? So using the table, we found out, where am I? This area has 20.54%. Okay, so how about this red area? Well, this will be 50% minus 20.54, right? Now, why am I doing this? Because I know everybody, I mean, to the left of this middle 178, you have 50%, right? So I have to, and I know that inside of this area I shaded with pink, that's 20.54. The rest of these are the people in the red area here. And so this will be 29.46%. Okay, so guess what? If your cholesterol is, according to these assumptions, okay, if your level is 200, you're in the top 30% of all the population, which actually is not so bad. And so the doctor will probably not give you medication yet, right? And they will probably make you or have you do exercises and eat healthy food and avoid this and this and that, all kinds of good stuff, right? But anyway, that's how you can calculate the percentage of people above and below you using these normal distribution. What is normally distributed? People's weights are, people's heights are, baby weights are, the duration of human pregnancies. Okay, that's normally distributed. Blood pressures are normally distributed. Pretty much everything you think of that involve a large number of people are normally distributed. All right. On the worksheet, you will get to study how heavy the British royal baby, Princess Charlotte, was at birth. And you will also find out things about filling in Coke bottles and things like that. Okay, again, the applications are almost limitless in normal distribution. Many decisions are made based on normal distributions. So don't take this lightly. I want you to at least be exposed to this idea, okay? All right, so this concludes lesson 14, which is also the end of chapter 5. All right, so after you watch this video, you can do your worksheet, okay, and you do the online worksheet as usual, and then you can work on your homework on chapter 5. And because this is the end of chapter 5, you also turn in all your homework, okay? And so that's what's happening. And the next topic we will study in the next chapter will be something completely different. All right, so this will be a good point to stop and reflect on what you learned. All right, once again, statistics, a very powerful tool, very practical, and you can't really live without all the implications of decisions made by statisticians and people who collect data. All right, so make sure you understand the big picture, big concept, and general ideas of how statistics works. Okay, all right, so until next time, I hope you will have a great week, and I will talk to you later. All right, bye.